the turn of Jim, who we talk about wildlife cameras and their use for citizen science, so we can see what we can catch. Thank you very much.
Can you see the screen? It's okay like this?
Yeah.
And the sound's okay?
Perfect.
Okay, so I'm going to talk about wildlife cameras or camera traps, as we call them, and how to use them. I have to say, it's not a new technology. We found back data from 1906. The first ones, which were really like a lot of wires and flash traps and whatever you want. But it definitely is emerging technology. The use is increasing at a tremendous speed. This is a graph which was published some years ago, but it's going very, very quick. And one of the reasons is that the price it drops down, although the professional ones we are using are still around 400 or 500 euros, some of them 300. People can buy them everywhere on the internet for less than 100 euros. So they become very accessible. As a researcher, we like them because they work 24 hours and 24 hours. So the bias or the observations during the night, which we were just talking, and the interactions during the night, wildlife or camera traps have no problem. And they work also in the weekends and so they always work. And the other nice thing about them is that there's hardly any disturbance of the species, because you place them in the field and then they stay over there and do their job without any specific problem. So that's the reason why they become so popular and why they're so often used. The fact that they are so cheap, or there are some very cheap ones, also is a big problem for citizen science, but I will get back to that later on. For those of you who don't really know how they work, in fact, they have a passive infrared, so BIR in there, who is looking all the time to its surroundings in different fields, and it's measuring temperature differences. So it's measuring all the time temperature differences in the image, and if one of those differences all of a sudden changes because something appears in the field, which is warmer or colder, then it takes 1 or 10 pictures, and then it takes again pictures and again pictures and again pictures. So depending on the cheap ones or the expensive ones, you have like only one field where it's looking, or it's looking at many different fields. And the ones who have different fields have the nice feature that they can look as well in the past or in the back of the image as in the front. So they can see small animals in the front as well as big animals further down in the image, which is very important if you want to take a lot of pictures. If we talk about, sorry, I wasn't seeing that you saw. So this is the different fields where you're looking. So you see this animal is out of the field, so you will not take a picture. But this one in the back is crossing from field 6 to field 5, so he will be photographed. And over there, this one will be photographed already all the time because he has been moving here in the view of the camera. What we do mostly, or what many people do, is trying to attach those cameras to a tree or to something fixed in the field, because otherwise your cameras have the tendency of disappearing pretty soon, except if you're working in a very remote area. Talking about camera traps, invasive species and citizen science. First, you have the invasive species. I think it's important to consider for what purpose we want to use them. And I will get back to it later on, but there is a big difference between early warning, where you want to detect them as soon as possible, or you want to have a confirmation of the presence of an animal in a certain area, which is a completely different setup or a completely different way of using camera traps if it's just to know if they're present, or finally, like we were discussing in the talk before, if we're interested in species interactions. It's definitely the case that camera traps offer a lot of opportunities for species interactions, because you can make multi-species models, because it's not, contrary to where we were used to, where wildlife people go out and monitor 1 or 2 species. These camera traps are monitoring all mid-sized species. However, there is definitely a bias, given that bigger animals are easier photographed than smaller ones, and this kind of problems. Getting to the citizen science, camera trap research has, in reality, 3 steps. First 2 steps of data collection and then the research. And the way we use citizens, you can subdivide in this 2-step process as being the citizen as a camera trapper or the citizen as an annotator. What do I mean? This is how citizen science and camera trapping works. Plenty of camera traps in the field. They all have SD cards or they send images, but preferably we still use SD cards. They go into a laptop, and then the laptop loads up all the images to preferable to a platform. In the old days, we didn't use online platforms. The disadvantage was that if this citizen stopped working or his camera or his computer crashed down, you lost a lot of information. So now we asked people, and I will get back to it later also, immediately load them up. So this is the, can you see my mouse if I'm moving? Okay, so this is the camera trapper, which can be done by a field technician, but which can as well be done by a citizen. And then once they're up there in the cloud, in the platform, then the images have to be annotated, which means someone has to say how many animals and which species is in which picture. This is the 2-step data collection process. Afterwards, the results go to the researcher who then does a lot of research. So I will start with the annotation and citizen science. Camera traps produce tremendous amounts of pictures. We have a small project with 40, mid-sized project with 40 camera traps running around all the time, and it creates 1 million pictures in 2-year time, which then someone has to look at. The nice thing is that the platforms, they bring the images together in what we call sequences. So they put all the images together until a predefined time, and in our study, it's 1 minute. Until there's 1 minute or 2 minutes of time between the last picture of one series and the next one. Why is this so nice? Because it reduces the amount of annotations you have to do. It's presenting all those images like it's a kind of a video. And then afterwards, you just have to say, well, in this 250 images that I just saw, it's a roe deer, it's a male adult roe deer and one unknown roe deer. So it's aggregating all those tons of pictures in what we would call an observation in research. So that's the first very important reducing step. The citizen, and I think that this is probably one of the most famous known citizen science camera trap projects. It's called Snapshot Serengeti. In reality, it was a lion project, but they uploaded all the images to Zooniverse project, where citizens all over the world could use this platform to say what was on the image, which species and how, and there was this user aiding tool to allow you to get through. And Zooniverse, in the meantime, this was the first one, and it's probably one of the biggest one. But in the meantime, Zooniverse has plenty of citizen science camera trap projects where camera trap images are uploaded and citizens are used to annotate. Recently, we're trying to get further and further and try to assess, for example, using citizens no longer to say which species, but to say if there were small animals, young animals, subadults, how many, so you can really start studying reproduction using this. This requires setting up a project at Zooniverse and loading up all images to everyone. And we see that for certain amount of citizen science projects, this is a bridge too far. People don't want to upload everything to everybody. We use another platform, which is called Agouti. Tim already mentioned it before. It was developed together with the Netherlands, with Wageningen University. Nice thing about Agouti for citizen science projects is that it allows you to create many different projects. And within each project, you can manage all the users, which means that you can, as I said before, you have a project coordinator, of course, and you have the researchers, and then you have the volunteers, but you can subdivide your volunteers in those are people who will simply do annotating work, or those are people who will do also camera trapping work in the field. So you keep these roles separated, and you can also decide yourself which citizens will be used. It's a lot of, I can imagine many people say, compared to other project setups with citizens, it's a lot of extra work because you have to give a role to a certain people. So it's not like a big open, like it's the Zooniverse, but it allows you also to get a certain kind of control on what kind of role which citizen can play in your project. As far as concerns a citizen as a camera trapper, there are many tasks which a field technician normally can do, which can be done by a citizen or a volunteer with a lot of interest. And the most classic one, which we also use, is changing the camera traps. If you have a project where your traps change location every month or twice a year or every 2, someone has to do it. And it's a lot of work because you have to put in cards, you have to retrieve the cards. We assess that it takes us about between 8 and 10 camera traps we can do a day, which means taking them on one place, putting them somewhere else. So you can imagine that it's very useful if citizens can do this. However, this is a very crucial step because doing this right is the key for the data afterwards. Which also means that if you send in people in the field to change places of 10 cameras and exchange SD cards, they have to do this very accurately. The nice thing about camera trapping is that it's very easy to standardize. We give coordinates to the people and ask them to go use a GPS, go somewhere, put the camera trap level using this small instrument. And one of the, as far as I'm concerned, biggest advantages of camera traps is, and it's a big difference with many other citizen science projects where we only have presence-only data. The camera trap provides us the effort from the first day till the last day. We know from when till when the observations were taking place. So we have an effort, and we don't have the people to ask to write it down when they started or when they placed the camera. It's all there. We discovered that there is a lot of professional work to guide the citizens. If you ask them to place the camera on the 1st of the month or in the first week of the month, be sure to ask it each time again, each month, because it dilutes very quickly. People do it the second week, the third week. So there is quite some managing of volunteers to do this. There is a very crucial fact of setting up the date and the hour of the camera correct. If this goes wrong, then the data are unusable afterwards. So we try to do it before. And as far as concerned, the third step, so if they get back with the SD card and they want to upload them, the internet is a crucial aspect. We lost some volunteers because their internet wasn't strong enough to upload images. And then it ended up, to be correctly, it ended up with 2 volunteers showing by every month at my house, giving me a USB because it's far more easy. And then I have to upload them because their internet is not strong enough. So there are ways around, but it's a crucial one. There are 2 different kind of ways, classical ways, which often happen. Citizens just decide themselves where they place the camera trap. All the garden projects running in Europe are now a classical example. People get or buy a camera trap, put it in the garden, and then upload the images they took in the garden or they took in their forest or whatever. So they decided themselves. The other approach which we are using and which 2 big projects did is where the researcher decides where the traps have to be, or at least give some kind of a protocol. There's one on the Appalachian Trail where they monitor the whole Appalachian Trail using volunteers, each managing one small part. There's a very big one in North Carolina, CANDID creators. And I took this example because they just published a very nice paper on the problems and solutions for this kind of large-scale citizen science projects. A lot of things which were said before reappear. There is a bias, just as Tom explained with the flicker, because people, it's very easy to have camera traps placed out in the field where many people live. But it's far more difficult if you want to do this in a very rural area. They finally decided to put in some extra professional staff because they were looking for this this goal of how to divide an underdeveloped, open and forested area, and they discovered that it didn't work if they just let the volunteers do it the way they wanted to do it. So they made it kind of a hybrid system where volunteers placed cameras at the same time as staff, with some extra cameras in the field to cover the whole setup of the project. Which brings me to the end. And some final things to discuss, so to final remarks. Private land in this camera trapping story always is a little bit of a hassle or a problem. And in two ways, sometimes access is a problem. If it's not the owner, who is the volunteer or the citizen participating, getting onto his land can be a problem. But we quite often have the problem in the other way around. People very willing, surely hunters or other people very willing to place camera traps on their land, on their hunting fields. Very willing to participate, but being completely against this being used as open data. They're really wanting to collaborate with us, but they don't want afterwards the pictures or the observations to be uploaded. So you get this kind of a catch-22 between having data from the private land, but not being able to open them, or not getting access to private land and then don't having the data. So I think it's something to think about. There is a big difference between citizens, which you use as what I call the dedicated volunteers, which are really interested in the topic, which you can pretty easy steer. But it's a completely different way of approaching individuals, like was done in the North Carolina or in the garden projects, where everybody can go to the library and borrow a camera trap for 1 month. It's a completely different way of setup, and it's also a completely different way of doing feedback. If you have a group of dedicated volunteers or citizens in your project, you can gather them, you can reach them, you can mail them. If you don't know who all those volunteers are, who just borrowed for one time a camera trap, it's another approach. And as far as concerns technology, as I said in the beginning, the market is going very quick. There are many very cheap cameras, but it is a decision in the beginning of a citizen science project. Do I want to standardize the camera traps we're going to use? And will they be all high quality? So it's very easy to compare and we have not too much of a bias. Or are we going to make a platform where everybody who has a camera trap and who used it can upload it? It will be far more difficult to compare the data collected from those different points. As far as concerns early warning for alien invasive species, invasive alien species. At the moment, we quite often have them as a bycatch. The project is aiming at something completely different, and then all of a sudden, raccoons or other species appear. So the bycatches of other projects. However, camera traps which transmit all the time images are being developed and are developing very quickly. Then the only thing is you have to capture somewhere all those images again, and somebody has to look at it, or, and that's the next step, artificial intelligence is going very quick at the moment. There are plenty of artificial intelligence or machine learning, which can determine very well. We're up to 90% now of the species on in the pictures, which is okay for invasive species. The problem is always that you have to have enough trained species or enough trained data of those invasive species in that environment, but it also goes very quickly. So I think that's making a big progress. And finally, we're moving now towards not only being able to determine the species, but also the location of the animal compared to the camera trap, which is a crucial one if we want to use it for science to do density estimations or other kind of research on how many animals or what's the density of the wildlife based on camera traps. So that's about it. This is one of the raccoons who was visiting one of the feeding stations. So it's a typical bycatch picture. That's about it. Time for questions.
Thank you very much, Jim. Very nice and worrying bycatch on this final slide. Thank you. Thanks a lot. Another interesting talk also for our morning. Thanks again, Jim. And we have Bernard. Yes, since a long time he's with his raised hand.
Yeah, thank you. Thank you, Jim, for this interesting talk. Actually, I didn't know about Agouti. I am almost for sure going to use it because we have a project now. It's the 6th year, I think. 60 cameras that, if they are not stolen, run from May to October in the mountains every year. Have lots of images.
Welcome. Sorry? You're welcome to use it. We'll be happy to
yeah, I will.
give access.
I mean, most of the time I have like students that have plenty of energy and want to check thousands of images, but I think Agouti is a good solution also for them to use it. But I have a couple of questions. Actually, we have now a paper in revision because there's a problem with privacy also with camera traps. And we made a survey a couple of years ago, and we realized that most of the researchers or the teams that were using camera traps weren't aware of how camera traps were violating the privacy things in their countries. Because of course, camera traps also take pictures of people. And in most of the places, it's just a violation of privacy. It's illegal. And so my question is, how do you deal with it in Agouti? I mean, because if I upload 50,000 pictures and there's people there, do you have a way to hide them, or I should filter them, or images keep private there, or how do you deal with this? That's one question, and the other one, and then you can answer to the second one as well. How are you working with AI? Because we tried to use the Google algorithms to identify species, and with like 600 to 800 images per species, we gave up because it didn't work. So how are you doing this with in Agouti? You are taking all the images from the different projects and try to train a system, or it's something that it's for the future?
Okay, I will start with the last one. Yes, because everybody has the same problem. If you use Agouti pictures, if you use Google pictures, then you have very nice pictures. And to make it very efficient, so like the 90–95% we are reaching now, you need pictures which were taken by a camera trap. So while we were lucky, let's put it this way, that we have many people who have been doing projects the last years. So we have thousands of annotated pictures of all the common species, which we wanted to be able to determine. So we gave them to the machine to learn based on real camera trap data and real camera trap pictures. And the people who did it from the University of Groningen, they made an algorithm which showed us like, okay, this one, we don't have enough pictures yet, or we need more information. We also have some classical problems like with wolves and dogs. So we needed a lot of enough pictures to be sure that the machine is right in determining this is a wolf and this is a dog. And so we are looking all the time, and we asked to all the different people using the Agouti platform, which if they still had pictures we could use to make the machine better. But it surely will be, so it's the way it's built right now is that Agouti can send your images to an AI module, let's put it this way. But it's constructed that you can send it to different artificial intelligence modules. So if people would build a second one, or there would be one existing for African species, which we didn't train, that you could tell I have a project in Africa and I only need those African species, please use this one. So it's in full development. And what happens is that the machine goes through the images, computer tell what he thinks it is, but then you still have the opportunity, or you can still check it as a researcher and confirm or saying it's not. So to give you the current situation, the model is built and we're now in the test phase of making it talking to Agouti all the time, because we want to be sure that it's not using too much of a delay and a communication of the system if all the images go up and down all the time. But this answers also your first question. One of the things the machine was very good in, the machine learning, is making the difference between empty sequences, which is also a lot, humans and animals. Good. So starting the moment we do projects where we really make it open to many volunteers, or we send them to Zooniverse. We have one project where they're sent up to Zooniverse to be really used by all citizens. Then the machine learning takes out all the people to avoid people being sent or being able to be identified by someone else. We have internal discussion, and we'll always be interested to know other people's opinions afterwards. What are we going to do with the images of which the machine says it's human beings? Do we destroy them? Or do we really delete them? Or do we keep them in the system, but don't present them? Some people say that because of the privacy, we really should get rid of them, delete them. Some of us feel that we should keep them to at least be able to control if the machine was right, that it's a human being. But it's really depending on the country. Some people say you're really not allowed even to store images of people. We think that we're not allowed to present them to other people because we could violate their privacy. But that's really a discussion on legal issues, I think. But that's also the reason why we glue on every camera trap in the field a sticker saying that they will only be used for research purposes of wild animals, and images of people will never be used or will be destroyed, because it's really a very sensitive point in using camera.
Thank you. We'll be in contact.
Thank you. Quentin is writing that it's good to make an observation that the human was present, because this is useful ecological data in some ways.
It definitely is the case. I mean, we do a project in a national park, and of course one of the interaction questions is if the animals are moving or displayed by more recreation. We have the same question now because of COVID. Are there more people coming to the parks? Are there more people visiting? So yes, you would like to have them, but it feels somewhere, yeah. Also, when you cannot publish them on GBIF, the pictures. So it's really I think we're also looking a little bit, and it would be good to have within Europe as much similarities or as much agreeing as possible on how to work.
So yeah, Quentin, so do you have a question too? Yeah.
Following up from that, we've been running camera traps just in the Botanic Garden for quite a few years, like 4 or 5 years.
Okay, sorry, could you speak loudly, please?
Sorry, no.
Thank you.
Yeah, we've been running camera traps in the Botanic Garden for 4 or 5 years, and of course we only have a certain suite of species we get. It's mostly foxes and deer, basically, and so and I thought it might be useful for early warning of invasive species, but we've had no raccoons and no muntjac deer yet, and but we've had some interesting things like polecats and marten things. Always good to see. But what I'm wondering is how we can actually analyze these data when there's also many biases and cameras break down, and can I was thinking I can look at activity of species, but not necessarily populations so easily. And I just wonder if you have some sort of insights of what sort of analysis you can do on these data.
Yeah, okay. In a nutshell, there are quite a lot of analysis or methods to analyze camera traps are based on whatever is called occupancy modeling and mixture modeling, and where you use the observations or the repeated observations from a camera trap, as long as you know the effort and you have the ones and the zeros, to estimate both abundance and the detection process. Because in fact, that's what you want. What you need to get to the densities is how well or is my detection probability influenced. So that's the without any extra measurements analysis of interactions between species, trends, occupancy, all this. This is a whole bunch of it. And then the second, and it's a field where we try to work on a lot because we're asked a lot. Can we get to real densities? And there is now a group of methods which is called random encounter models, REST models, and others, which use the distance of the field, the probability of taking a picture of an animal, which is based on a random encounter model. The main problem there is that you need to have an estimation of the distance between the camera and the animal you observe. In Southern Europe, it's not so difficult because you can put landmarks because the vegetation is not growing too quickly. In our regions, it is difficult because it's changing all year long. Together with Marcus Rockliffe from ZSL, we're now looking at methods to determine from the image itself the distance between the camera trap and the animal, which would then allow you to calculate speed and this kind of information. And then it opens again. So the methods are available, but the problem is that at the moment you need to do some extra measurements in the field. If camera traps are standing at the same place always, it makes life a lot easier. Many people then for this view determine that this tree or they put some marks in the field, determine the distances, and then it becomes a lot easier to calculate distances. Distances and then densities. But it still is one of the research fields where a lot of work is going on. There's plenty of publications. I can really share some, but it's not on the shelf ready to be applied.
Thank you, Jim. I guess, Bernard, your raised
Sorry, yeah.
hand is from before, yeah, just to be sure. Okay, so I don't see any other hands and other comments in the chat. So thanks a lot again, Jim, for the very interesting and great talk also on wildlife camera. How it ended between the roe deer and the raccoon? I'm curious,
I don't know. I don't know. We have, as often with this kind of interaction.
It's
open. I guess one of them backed off, but it is really funny to see sometimes interactions on camera between an animal standing there, then moving up his head, and then all of a sudden you see a second animal or a second species popping up in the image. We have already quite
so great for the. Sorry.
No problem. Okay. Up to you again.
No, great for species interaction data.
How do I stop sharing?
Yeah, sorry. I have a little bit of delay. I'm sorry. Please go ahead, Jim, if you want to say.
No problem. I was just looking how to stop sharing. Okay.
I have a little follow-up question, actually. If there is time, I don't know what time we're on, but it was just that one thing I noticed in our camera traps is we catch a lot of birds, really a lot. But what I notice is that because it's in the sub-canopy level, is you get a very, very, it's like looking at the bird fauna through a letterbox. That you own, like you get great tits, but you don't get blue tits because, and I never realized, but apparently blue tits are more high canopy type things. And do you identify all the birds? You do,
Yes,
yeah.
we do.
And
But you should also know that like we have the muskrat project where the cameras are looking at the water really, so you get a lot of water birds and that will be, I think, if we want to go to, I mean, you upload those data to GBIF and then they're being used by real gathering machines, then the metadata standards will be very important to know how the camera was placed, at what height it was placed. And so together with our LiveEdge people on the open data, there is now a data package created, published, standardized, where it's always the same 3 fields. And we will be using them for Agouti and Trapper, which is from Bielowice people, which is not a known platform. We use the same standard. So whatever now is developed in R and analyzes packages, they're built on the same standard. So at least the metadata are the same, because it really was a problem in the beginning with camera trapping. You were always wondering, was it at 30 centimeters, 80 centimeters, 1 meter high? How did they place them? Did they face north? So that's now starting to be standardized also. And it will be, it's also on the website of the TVG. I will share it also.
So thanks again, Jim, also for the last answer.